Wednesday night
Recording is on.
meeting. Nobody knew. Hi, Frank.
Hi, how you doing?
Good. How are you?
Great.
Checking. Eric. Okay. I just wanted to check and make sure. Okay. So tonight's meeting, we're going to Wayne's going to do KiCad 101 presentation. Then I will be doing a very quick DCR update as to where we're standing right now. And then we'll be open for questions or roundtable or whatever you'd like. So, Wayne, if you're ready to go.
Yeah, and before I start and maybe embarrass myself because Murphy will take over, I wanted to ask what's the CAD tool being used to do the DCR project?
I'm
Eagle?
not quite. No, I don't think. Is it Eagle? It might be because it's Kelly Gray that does all the work. He teaches at Humber College. They have a milling machine, so he does all our layouts and everything.
Okay. Alrighty then. All right, so I'm going to share my screen. This has been tested twice since I last failed. I think I should turn my camera off. Start sharing my screen. I'm going to do full screen first and then hide. And if everything worked, you're looking at a picture of EE schema.
Yep.
Awesomeness. Yep. That worked. I'm going to go to the actual main program first. To start off, this is the actual, they call it the program manager. It's basically the launching tool for KiCad. And this is what I'm going to do is just talk to the history a little bit. And this is straight off the wiki page. And you probably don't care that much, but it's actually quite an old product, which surprised me. It was first developed in 1992 by a guy named Charras, probably Charras because he's French. It was first developed in France, and I gather it sort of caught its own steam for a while. What happened was in 2013, CERN, the giant cyclotron guys, the nuclear physics guys, actually took on the KiCad project itself, took it over, and they threw resources at it, and they developed it. And I don't know what their first release was, but in 2015, what was called KiCad 4 was released in the world. And when you're going out and looking for information on it, sometimes you still find KiCad 4 stuff, sometimes you find KiCad 5 stuff. The current release is KiCad 5.10, which I have installed, and version 6 is imminent. From what I've read, the user interface is slowly, changes to the user interface are actually slowing down, but there was a lot of changes to where they put stuff in earlier versions. And what that really means is if you're shopping around for YouTube videos on how to use this tool, quite often you'll find that the guy is doing something you just don't see on the screen because you don't find it on your menus. Yeah, it's still there, but they change things around, and they used to do it a lot, and I think they've tapered off because I think they're getting close to sort of, they've got all the features they want, I think, maybe, and so they don't need to do it so much. So that said, after you wait for the 1-point-something gigabytes of data to be downloaded from the website, and you run this program, this is what shows up first. So it's just a browser that allows you to select a project and start a new project. On the icons here, this is what you're working with, and I just want to talk to them because we won't see them for a while. This useless thing on the right here is actually to allow you to change the format of the pages. If that makes sense. That's basically the outline, and this is where your fields go, where you're going to say, this is my name, this is my project. So you can make it bigger or smaller on this editor if you wish to, and it becomes, I think, a permanent part of the tool. It changes all diagrams. The calculator, I think, is kind of cool because it's not a normal calculator. let's just continue. Give me the calculator. Oops, I just closed it by accident. It's a little sensitive. You don't double click on this thing, you click once and that's it. So it's got a number of calculators that are useful for design of electronics. It's opened on the transmission line calculator, which kind of gives you the rough dimensions you need depending on what you're trying to do. Well, handy color code thing if you're not aware of the color codes. I actually don't know what board classes are. Standard RF attenuator type thing. Trackowid is actually somewhere it might be useful. Its purpose is it tells you how big the tracks need to be on the PCB board based on the amount of current you're trying to shunt through them. So if it's a big amount of current, you want a lot of copper. And so this basically, you fill in the parameters, it basically tells you how big it is. The other parts of here, I won't do the bitmap to component converter. It's very rare you'll actually think of that. The Gerber viewer. So what the Gerber viewer is, it's used in the next session. What it is you export your KiCad model into Gerber format. It's what you send across to a manufacturer to get your board manufactured. The viewer is used to demonstrate to yourself that you're not about to make an expensive mistake, because it will show you what you'll get back, provided it works. But I've seen it, actually, I've tried it, and I've actually noticed things I couldn't see in the PCB editor were not visible to me until I went to the final format. This is the PCB layout editor, which we will be doing next week. I don't want to order that, thank you. This is the symbol editor, which allows you to create new symbols if you want to. This is the footprint editor, same thing, allows you to create new footprints. So the big thing about a PCB designer is you need to be able to take a logical model, which is a schematic, and tell the tool what the components physically look like. Because if you have, for example, a resistor, it could be a giant through-hole half-watt resistor, or it could be an SMD transistor. Those are different footprints. So for every symbol that you might find, there could be many, many footprints that are appropriate for it, depending on the type of PCB you're building. Okay, so these are generally are delivered. The footprint editors are not coupled directly to the symbols. Usually, I think you can do that. I haven't seen it. Along with the footprints, there's one other thing that's called the it's called a 3D model, and what it's used for is when you're looking at your actual PCB when you develop it, it allows you to actually see the components sitting on the surface of the board, and it's handy to see if you have any problems with clearance for purposes of soldering, things like that. Now I have the thing we're trying to make up here, and let's just turn on the field zones. This is what it looks like when you're looking at it from the board design view. I'm looking at the back. Here's the front. This is the PCB layout that I'll be working on. It's not ready yet, so the only thing I want to show you is the 3D viewer. This is what you get to see, and you can see that there are two components on either side of this board, which is a 6-pole QER filter. There are crystals here, and there are some capacitors that are rendered as the block capacitors. So you can see how that might be useful if you have a very crowded board. You can have a look around at all dimensions, right? So that's basically the majority of the things that are going on. And I wanted to take you into the schematic. I think I got it open already, so I'll see if I got one open. Yeah, I got one open. This is the schematic that I was starting with. I already have components on here, but what I'm going to do is spend a few minutes just going over the screen here. It's a little busy maybe, or complex. I find KiCad is very rich in things you can do with it, and it's hard to assimilate them all, but you don't need to know them all at the same time, I guess. So let's go with it. You got two sides of the board, have images or icons on them. You've got a icon list at the top, and you got a menu system. When you're using KiCad, oh, I have to tell you something. I call it KiCad or KiCad. It's supposed to be called KiCad because that's the French pronunciation, right? I started calling it KiCad before I learned that, and I will fail to give it the right name a lot in this demo. All right, so the file menu you'll almost never use. I'm going to start with the first thing you want to do when you open a diagram. This has got stuff on it. You probably want to go to what's called page settings, and that's just basically the editor that allows you to stick these properties in the bottom right to tell you what the name of the project is and what the name of the diagram in the project is and who you are and all that sort of stuff. Once you've done that, you just OK and you're done. Another thing you hit the menu for is preferences. And that is usually when you need help. And I wanted to point out every hotkey is under the preferences hotkey. So if you can just remember to find the preferences menu and walk it. If you can't remember the hotkey that I'm showing you, well, there's a hotkey for everything. You can find them here, OK? There's one other reason, or maybe two, for going to preferences, but that's mostly what you do. So the reason you don't go to any of these other things is for the most part, everything that's under these menus is sitting on the screen on one of these menus here. So the next thing you want to do when you start up is inches versus millimeters. It might be a good idea to use millimeters. There is a grid feature, which hides or shows grids. I can barely see it on my screen, and there's a good chance you can't see it at all. But there is a small grid that allows you to find your center your cursor on something, and you'll be using it. And I'll show you in a moment why you care about that. This little icon on the bottom, it says, "Do you want to draw in any direction, or do you want to just draw vertical or not?" So I can't remember which is which. So by draw, I mean if I put a wire on here, kind of go up and down at an angle. This is not letting me do that, which tells me this setting, excuse me, this setting here where it's got a it's blue covered. That means it's strictly horizontal and vertical lines, so you can't draw a wire at an angle, which I tend to prefer. Show hidden pins is a feature I don't use too often, but sometimes, I don't know, a schematic symbol has elements that show on it that you don't need to actually show because they're not necessarily used, and you can get rid of them here. That's a little bit different than saying a pin is not connected. There's something on the right-hand side for that I'll show you. But finally, the only thing I can give you advice on is the cursor shape. This is the cursor shape I go with, and I do recommend it. What the cursor is a long horizontal line and a long vertical line. The alternate way of looking at it is a short crosshair. It's still pretty big, but this is really important, I think, when you're drawing schematics to be able to have it. Now, you notice I've sort of dragged myself way off the center of the screen. When you want to move things around, you put your cursor anywhere, click the center scroll mouse, or I've got a roll, what do you call it, a wheel? It's useful to have a wheel on your mouse for this particular thing, because the wheel rolling it one way makes it bigger, and the other way makes it smaller, okay? So if you've used LT-Spice, there's some things that are similar. I mean, it has the same capabilities as the schematic editor in LT-Spice, I would say, but all the keys that you would select to use them for are different. Now, when I'm actually on the grid, you have zoom in, which is a function key, which I should probably hit. F1 is in, F2 is out, etc. You can learn that if you want. I use the mouse, so I never bothered to learn these things. Redraw view is F3, it just basically redraws the view. Zoom to fit, the home key is useful, does that, from which you can scroll up. The big key that I use a lot is the give me the center where my cursor is. That's function key 4. Okay, so if I move my cursor around and hit F4, it moves the diagram so that I'm centered over that. And it's really handy, as we'll see in a moment. I need to show you which of these things on the right-hand side are the most useful. Highlight net, I almost never use. what that's for is you've got a lot of wires in there and you're trying to find out where the ground is across the entire diagram. You can click on a wire that you know is ground, hit that, and it'll highlight all the wires that are connected to ground, okay? This is the add component, or add symbol, and I'll be using it in a second. This is add a power symbol, which is either the voltage or the ground, or one special symbol that I'll have to get into. And this is the connect a wire. These are the most common things you're going to be using. As we move below here, there's things that you less often use. So these sections here, these three, are for buses. A bus is a whole bunch of wires that you want to hide in your diagram because it's messy. So you connect them inside a bus and you draw a wire that is called a bus. I haven't had a chance or a reason to actually use this yet because I have not done anything sophisticated. So I'm going to leave that to later because I'm going to just nominate that as maybe a little bit more advanced. I have used the place no connection flag. Now what that is if there is a component on your board that doesn't need to be connected, and typically you're talking about the pin on an IC that's not used in your thing, like a microprocessor if it's on your diagram. You might be using one pin of a microprocessor and leaving all the rest of them off. You put a little thing like that on the page and it tells KiCad that it's intentionally left unconnected. Don't give me any errors. Please don't bother me about it when you move to the diagram. All right, so that's that. And the final thing that I might use is place a junction. You normally don't have to do this because you can make junctions when you're drawing wires. Then there's a big section on subdiagrams if you want to use subdiagrams. I'm not going to show you that today. A reason you might want to use a subdiagram is what I just said. If you have a microcontroller, it's got a lot of pins on it. If you want to have a diagram that isn't too busy, you can drop the microcontroller and maybe the pins it's connected, not the pins it's connected to, but the sockets that you want it to connect to, the female or the male sockets. You can put those in a subdiagram. And then you use the features on the right-hand side to name the wires which should be appearing as the parts that appear in the subdiagram on this thing. So a subdiagram will appear as kind of like a box with lines coming out of it. Those are the wires that you want to show on the parent diagram. So your microcontroller disappears into a box, and you have a few wires coming out, and you have the power and ground going in and that sort of stuff. Okay, that's what it's for. Enough on that. Sometimes you want text on your diagram. I have text in this diagram, I think. Oops, let me just scroll down. Yeah, I put some text on here, and I also grabbed my component by accident. So you can add text. This little dotted line here is for adding boxes to partition your diagram if you want it. Okay, so that basically explains all that stuff. What I think you want to remember is place a component, place a wire, and that gets you 99% of the way through. So let's go look at the component placement first. This is similar to what LT-Spice offers, but it, of course, works a lot differently because it's a different product. What you do is you first find where you want to drop the part. There is a delay like this the very first time you use this feature in the schematic editor, and then you don't see it anymore. What it's really done is it's read through the entire library of symbols and brought them into memory. When you're in the PCB editor, it also does the same thing when you're dealing with footprints, by the way. Okay, so I'm building a filter, which you see part of here, and I'm just going to duplicate some parts so you can see how to add them. What the filter is, it's a crystal filter. It's a whack load of crystals, a bunch of capacitors, a terminating transformer, a coax connector, because I like to go big, and a ground, or two, right? So you can add grounds all you want. So what I'm going to do is just find the components for you and explain what we're looking at here. So this is how KiCad organizes the standard libraries. It comes out of the box this way. You can add more libraries. When you add a library, it gets its own line. Now, farther down below here, I've actually loaded Oh, I can't see it this way. I better go this way. I've loaded the DigiKey library, which is not out of the box. It's actually, where is it? Oh no, I haven't drawn it for symbols. I'm sorry, I did it for footprints. Okay, so nothing to show here. But you can add libraries of your own, and everything in the library will appear in the library. So the reason that Geekheaders are organized this way, they've kind of like done a logical grouping. So if you know what you're looking for, you can find it quickly by just finding it within a selection here. So for example, if I want to find connections, I'm going to go connector. And in the connector, I have a couple of things. Actually, I have lots of things in connectors, what I'm saying. These 1 or 2 or 5 pin connectors, these are male or female type connectors. So these are the standard pin connectors, pin headers that you're used to. One thing you don't do with the logical schema elements that I have to make clear here is this is not the component footprint. The footprint could be, 2.54 millimeters apart, 5 millimeters apart, or something different than that. You know, it's not really the component. You have to do a separate step to find that. What I'm going to look for is coax. Here's connector coax, and that's what it looks like. So now that I've picked a part, all right, what you do is you say, okay, and you're ready to drop your part. And you can drop your part. Note that on the top left, I'm still in add part mode, so I can go click another part. And what it does is it's still showing the thing that I just selected. And I wanted to show you, it says recently used. So you'll always see in the current diagram all the previous parts you added, so you don't have to search for them. You know, like if you had a bunch of resistors to add, you go here, okay? Now, oh yeah, so maybe I'll just add that for now. Okay, click there. To get out of adding components, you hit the escape key. There's a couple of things with this component. When I was adding it, I could have done this, but if you focus your cursor over the part, now I'm going to roll up a bit so you can see it more easily. There's some things you can do with the part. Well, I can move it. Obviously, that's helpful. I can drag it around, okay? I can drag it. Drag it doesn't make sense unless you have a wire. It drags the component and keeps the wire attached. This is, in my opinion, a very useless thing to do because it messes up your diagram. There's an orientation for rotating. One of the things you do with this sort of stuff is pin 1, which you can see, is connected to the circuit. So maybe on the left-hand side, you want it rotated. Oops, I did the wrong thing, so I'm going to hit the Control-Z to undo that. I hit orientation mirror around vertical axis is what I meant to hit. There we go. And that allows you, if you want to just sort of move that over, you can bring it over to wherever you want. And that kind of looks like what I just did. Okay. All right, so other things you might want to remember when you're doing adding components is this is a European-made product. And if you fancy the IEEE standard for things like resistors, you need to remember to say R underscore, here's R. See how it uses a box for the resistor? If you use RS, you see the squiggly line that I grew up with and I'm actually still comfortable with. I don't care that much, but you can pick shall we say, I think this is called the IEEE standard. There's an ISO standard, I think, corresponding to what the Europeans are using, and I don't remember what it is. You sometimes have to add underscore US if you don't see the shape of the symbol that you're most comfortable with. So that's the thing I wanted you to know. Need to show you power and ground. So what you do is you click on this, then you click here. PSpice. It does do PSpice. All right, I'm not going to talk about PSpice today, but I should have mentioned that this comes with a fully equipped, apparently, PSpice simulator if you want to explore that. If you're interested, I might try it, but I'm into LT Spice. Took me a year and a half to try to get to where I am, so I don't think I really need to go there. So you have different power symbols, which you see there. Just by clicking on it, you get to see the symbol itself. They're all the same. You have ground, and to find them, you type TND. This appears to be more or less a safe ground symbol to use. You notice I use I think that's, what do they call that again? Earth, I think. So let's have a look at ground. Let's see if I can find Earth. There it is. Yeah. So, when I was first doing diagrams, I guess everything, chassis ground, who heard about that? They're all earth grounds, man. Okay. I think I've covered this enough. Now, before I move on from the symbols, you can stop me now, and now's a good time because I'm going to start wiring stuff and show you the problems with you. Okay, so wiring sounds simple, but if you take the picture out to a decent distance for drawing, and then you kind of like oh, I'm sorry, Wayne forgot to say, first thing you do is you click on the place wire symbol. It also pulls up it says place wire under it, so it's easy enough to find. It's the green one. And you place a wire, and sure. And it does this stuff. It's doing this for a reason. It's having trouble finding the spot. Generally speaking, you have to bring it really close to you before you can do that. And there's another reason it's doing this, which I learned kind of recently. And it has to do with the size of the grid. What's going on is it can't find the end of this thing for some stupid reason. If I go to the grid here and just show you what you do with the grid. The grid is set to 2.2.4. I just make it smaller, and maybe it'll work. All right, so I'm going to continue to do this here. All right, if it doesn't work, actually it's not been this bad before. I'm going to move the part till it's on a dot. I don't think you guys, because I tested with Michael, he could not see the dots. What I just did is this circle.
Yeah, we can see the dots. I can see the dots.
Okay, so if you can't see the dots, I put the circle over a dot. That's what you got to do, I think, for it to realize that that's the end of the part. Okay. The other thing you can see is these things aren't really lined up. I just want to close it here and double click it like so. Yeah, perfect. Okay. Do you see these square guys? They're very easy to get on your diagram, and what they're telling is you didn't nail the wire. So, I mean, a lesson for this is put your diagram pretty big at the points where you're making the connections. So I'm going to pretend I'm dealing with a diagram that's much bigger than this. I'm using the delete key to delete these things I added. Oops. Control Z, folks. Remember that. You're going to want to learn it a lot. See if I can get it. Nope. A little bigger. Control Z. See if I can hit this guy and delete it. Control Z. Okay, I'm just going to give up on that for now. Move him down there and delete him. And get back to the exercise. These aren't lined up. They should be lined up because you have troubles later if you don't. But I'll show you what it looks like. With it large, start there, you go there, and you can line it up there. If you wanted to bend it sort of here, this is why you want the big wide cursor, folks. You can see that I've lined it up to the second part. I clicked the mouse once on the left button on the mouse to cause it to have a bend in it. I found the center, and I go straight across. And that is what you expect to see. There is no box around here. There's no line around there. And that's what you're expecting to see. Now, if you're working at this level, it's fine, of course. You can't move this thing, you can't ever move this thing again, because what it does is, here's drag. The drag looks like this. Oops, that's drag. Yeah, sorry, drag. Oh, I took it off the wire again. Nope. Oh, hang on. Always remember the Control Z, man. Drag is G. Well, actually, it was G. It was another character. Do you see how it does that? It won't reorient the line no matter what you do. So if you're trying to get these things to line them up first, then draw the lines, or you'll be deleting segments of lines. Okay? So what you want to do is have your diagram lined up in the way you want by placing all of the components before you do any wires. And that is, I think, maybe it doesn't matter in LT Spice, but it never troubled me as much, I guess. All right? What else can I show you before I move to the next stage? So this is, what I'm trying to show you is the part that's the most similar to LT Spice schematic drawing is laying out the wires and stuff like that. I hope you guys are comfortable with that, because I want to go next to show you the evolution of the diagram and some other features which are very specific to building a PCB that's like novel. I'll also point out, now that you can see it, I know you probably noticed this right away, is the numbers aren't on your page. You don't see numbers for any of your symbols. And of course, your components, you don't see any values. If you really are interested in editing the component values at any time, you simply hover the cursor over a component and hit the edit key. I think this is similar to LT Spice, that the thing called value is where you put, you know, I'm actually making a QER board. I don't want to lock it down on what the values are, but I can do that for the purposes of demonstration, right? But if you think about it, you don't need to type anything here. The other part, the numbers, there's a little feature that I'm going to show you in a moment that allows you to automatically number the entire board. And part of the reason I'm talking about alignment is it automatically orients things in a very specific fashion, which almost kind of dictates how you want to lay your board out in order to make it work well. All right, so what I'm going to do is switch to a picture. I'm not sure which one I want. I think it's 3. That is actually the board with enough components to do a 6-pole QER filter, and with all the wires connected. And I need to do that by going back to my launcher. I put everything in one file, and hopefully this is the right one. Yeah, okay, there you go. All right. So, okay, so this is where you are when you've sort of wired it up. Total time to do this for me was about half an hour, because I was essentially messing around with the wires quite a lot. You know, moving things around, realizing I made a mistake. They're still not lined up, which is a good thing, because I'm going to do the annotate feature next. Now, there's a bunch of things up here, which are really what you use a lot. Okay, footprint editor I use quite frequently, but not so much for this demo. Annotate schematic symbols. That's the first thing you want to do. That's why I've got this sign up here to remind me. What this is going to do is automatically annotate. If you look at the way the diagram is drawn, it's probably not evident. Everything lines up vertically, but not horizontally. Okay, so what I'm going to do is sort components by Y position. Now, what you're going to do is start with the order. What this is trying to do is run like you read it's going to run the numbering like you read a book. Starting with a line, you go left to right, next line, left to right, next line, all the way down to the bottom of the page. Okay. Second thing you have to hit is reset existing. Keep existing is not going to help you not. What this is for, by the way, is you're adding new parts as you go, and you want to annotate them as you go. Okay. So this is a complete re-annotate. Clear and annotate, yes, please. Okay, so you can see it's put Y1 here, Y4 here, Y3, and so on. But what happened to Y2? Is Y2 here? Good. Y8 is here. So maybe that's the way you want it, or maybe you want this one to be wide too. So if you were to do the other component, annotate, clear and annotate. Oh, I should show you what's wrong with this thing before I start. Close, cancel, close. You see how J1 sitting on the right and J2 sitting on the left? This doesn't matter to me at all because the filter's symmetrical, okay? It just doesn't make any difference. but I could imagine that if you're drawing an amplifier, it might be kind of important that your input is named correctly, okay? KiCad allows you to basically go in here and directly edit the, where's edit? It doesn't show me the keys, so just hit the E key. You can change the reference to J2, then change J2 to J1. In LT Spice, because it's directly connected to the Spice model, it prohibits you from making that kind of a change because all names must be unique in the LT Spice model, right? So, okay. But what I'm going to do is the quick and dirty one. I will annotate it by up and down, the default, and I do want to reset it as sync annotations. Okay, that looks right. Okay, so now I've done that. So I close it. Everything's annotated. If I choose to do naming a crystal filter like this, like I want to say this is a 10 megahertz crystal filter, and all the, because of the design model, all the capacitors have the same value. There's a really nice feature a couple over here. So where are you here, little fella? Edit symbol fields. Actually, the camera's sitting in front of my, in front of my screen, so I can't see these things here. All right. So what the edit field things is allow you to do a bulk edit or a partial bulk edit if you want to. So what it says here is C1 to C10 are labeled C. Well, why don't I just set them to a nominal 100 picofarads? I don't want to change J1 and J2 because that's what it is. Why don't I change crystal to 10 megahertz? Like so. Okay. I apply. Okay. And I've done so. Now I've locked my design down to a single frequency. But that, see where this comes in play, I think, is a number of types of designs use something like a nominal crystal value, a capacitor value of like 100 nanofarads for a blocking capacitor, and they're all over the place. You can go to this screen and you can find them and select them and set them all to the same value. I could have chosen to, where are you, little guy? Gone into this crystal filter and done, see, I think I can select these three and just change them all at the same time, okay? Okay, so that's the part where I supply the numbers to the design. So there's only a couple of more steps you have to do. You should do a run electrical check. I'll break one connection first to show you an error that you would expect and one that you wouldn't expect. Okay, so I've left something off my transformer. If you run the design rules, which is the bug thing, it gives you two errors, and it puts arrows by them. So if I were to actually select no connection, it actually highlights for me, puts my cursor right on it. So what I would do is I just reconnect that line. So it finds all the parts you left unconnected. Sometimes that means you want to hit the little X thing that I showed you here and say, I didn't mean to connect it on purpose. So, you know, like, shut up, KiCad, I don't want to hear about it. So I'll use Control Z here. But there's another error message, which is hard to explain. Did I do something wrong here? Oh yeah, it's actually pointing out the one thing. So it's giving you two error messages for this, I think. Oh no, I just didn't do it right. Let's go Z and Z. What I must have done is when I drew the line that I drew, I didn't have myself close enough to the darn thing. So it was broken before I started this. So just going to draw a line, bring it down here, connect it, hit the delete key, and that ought to be connected. And even if it's not, we're going to say it was. This error here is actually saying it's a feature of KiCad. It's not quite smart enough to know where the power and ground connections are. The reason you have this in KiCad is most of the time your power is coming off board on something like, you know, a 1 of 10 pin connector. So you need to tell it which of the wires coming into KiCad, into the diagram, is the original power supply and which one is the ground. Now it does this to me because I don't have a ground thing. This is not an error exactly. It's a warning message that it will give you and it won't go away. I can generate a PCB with this thing and it will still work, okay? But the fix, you want to make the error message go away, and everybody I've seen that does this fixes the error message because they consider it to be good hygiene. Is you click on the line, you click on, let's see here, and you go to PSpice power, and you type this very special power flag. Don't worry about remembering this thing, because the number one question seems to be, what the hell is this power flag supposed to be there for? And you will find it. I'm going to orient this thing counterclockwise. And then I'm going to attach it very carefully there, okay? I'm not going to run this again. It disappears the error message, okay? So the power flag is I don't know, it's like KiCad is not as smart as you are kind of thing. You have to know to do it. Once you do it, generally it makes the errors go away. So finally, actually second to finally, what you're going to do is, the thing that makes this unique is that go to this board. So this may, I forgot to load this before I started. It takes longer than the symbol editor does to run, and that's because there's many footprints, many more, like it's, I don't know, 4 to 1 or something, I don't know, a lot of them. Okay, yes, whatever you said, I don't know what you're complaining about. Okay, it's giving me this error message again. I know what's causing that. I just don't know how to fix it permanently. So what this means is it couldn't find the part. Do I want to fix this? Yeah, I think I want to try to fix this before we go, Fred. Let me do preferences. No. There's a feature problem that I'm having with the upstairs version of this thing. You may have remembered that I had to install this on my upstairs machine so that I can actually make this work. Now, still seeing this error. So I'm not going to be able to fix this just yet. I'm going to see if there's anything I can reach so that I can do this demonstration. There's my footprints. Assign footprints to, and I'm going to look for transformers because that's worked before. Actually, I had this working this morning, by the way. It's just the way it seems to work. Okay, what's going on is it doesn't know where the file is for capacitors. It doesn't know where the file is for crystals, and it's not going to let me attach those things. So I'm just going to do the transformer right now because it does find that, and I knew that. All right, so what you're looking at on the screen is the thing that you use to put a symbol by everything. Generally speaking, if you have a lot of things with the same value or the same type, you would select a whole bunch of them, and then you'd go over here and you'd find the footprints. I'm going to do the transformers, and I'm going to look for them. What I want for my crystal filter is I want a torite. And I found it earlier, so I can find it by going to the Transformers library, checking amidon, and then looking through amidon. And what you see is horizontal ones. You see different sizes. I'm going to pick the D37 size because that sounds good. And I want to pretend I'm not sure what it looks like. So up here, there's a view selected footprint. So the footprint will show you what the component footpad looks like, and it allows you to get a good sense of whether you got the right footprint or not. It's showing me the things lying on its side, basically. Inside the footprint, there's also a 3D display, which unfortunately for the footprint that I've chosen is not equipped with a picture of a toroid, but often they are. The crystals will. If I could figure out what's causing that nasty problem with not showing me any capacitors, I would be able to do this. And now I can show you in my own footprints, I think. Okay, so I'm making a bunch of Manhattan footprints for another project. So I should show you what it looks like. Oh, good. I borrowed this thing. This is my not Manhattan yet version. I haven't edited it yet. So that's what the capacitor actually is going to look like. And this is a copy of the original library, which I was doing quite comfortably until this thing broke. So actually, I could make everything go there. So let me just say, okay. Whoops. I need to tell you a little problem with this thing that you need to be aware of. And I'm just about done. All right, for these capacitors, I'm going to go to, you notice it's showing you, let me see if I can find capacitors now. Look at that, you can see them now. Sorry about this, guys. The problem I'm seeing has to do with the configuration upstairs after installing version 10. I don't expect everyone will see this, but I can't actually tell you why it's happening. I know exactly where it is, and I have fixed it in the past. I pick this. Okay, fine. Does this have a picture? Okay, fine. I could pick this if I want for those. Now, I want to explain this weird naming convention. If you see a P, P means pitch. Pitch means the distance between pins. Generally speaking, you want to know that. You take your calipers and you measure the width of the capacitors you got lying around. Or if you're using SMD, you have to know the sizes of the 1206 or the 80, whatever it is. And you pick the one that's appropriate size. These other two dimensions is the length of the box, I think, or I think it's the length of the box, but it might be the length of the actual component. And this is the diameter of the component, kind of like that. So if I were to select that, oh, I did it again, and it didn't tell you what I was doing wrong. Okay, one more try. I'll get off the pot in a moment. What I have been doing wrong is the OK button is staring me in the face, and I really, really want to hit that OK button. What you actually do is you double click, and that's what loads the sucker, okay? I may be able to do crystals just as easily. Crystals here. And I want HC 49. Yeah. I want a vertical HC 49. That's it. No, HC 49. There it is. So double click that. If I select this all like that, I've done them all, and so on. Now, I think I'll stop there and you respect your time a little bit. It's taking a bit longer than I expected. Once you've got all the footprint selected, you're ready to go. The last thing you want to do is hit the generate the net list. The net list is an interchange file that's used by PCB layout editor. So you just take PCB view, generate net list. It gives you the name. If you save it, you're done. Okay. So the biggest part of this problem, I think, will be finding the right footprints. I found personally that I can't find certain footprints know-how. I actually don't have the right SMA connectors on my libraries for the board I want to bake. And I don't know why that is, because they seem to me to be the most common type. They're the small SMA horizontal connectors. But you can make your own connectors if you choose to, and I've been working with that just to get used to it on another project. So I'll be able to talk to that later if necessary. All right, so I will mention one thing. This is where you get your bill of materials from. When they say generate a bill of materials, they mean give me a CSV file in various different formats that you might like to get. I've tried a few of these things, and I think frankly, they're quite useless. The point here is the developers of KiCad know full well that there's other people out building third-party add-ons. There's apparently a third-party add-on for bill of materials that I haven't tried yet. It's probably designed to be more usable than the ones I'm seeing here. And essentially any specialist can build particular toolbox and add them onto this thing because it is in fact an open system product. You can extend it any way you want. There's an auto writer for the PCB editor that's available externally and things of that nature. I'm going to stop now, but I'm going to just keep on a diagram for a second. Anybody can ask questions. I can't see who's got their hands up, but if there's questions about, how do I do this, or I missed something that might be valuable to do while I still have the diagram up, let me know.
I've got a question.
Sure.
At the very beginning, when you're putting your first component on, or you're going to put a bunch of components on, can you make a setting that requires that each component you put on actually snaps to the grid so you don't have that problem that you demonstrated?
I don't know the answer to that question. It doesn't seem to work that way out of the box. It might be, yeah, I'll take that away. I don't know about it, but it's easy to find stuff in here. I didn't actually notice that previously, so it may have been snapping to grid for me because of when I laid it out. So what you might be seeing here is when I drew the diagram originally, I had a different grid setting than I did now, but I don't think so. I think it saves the grid setting when you save the file. So it ought to have been able to draw the lines. No, wait a minute. Where did I have that problem? Yeah, I think I was looking at this developed diagram when I surfaced the problem. So in my opinion, it ought to have worked when I redrew the line because it should have had the same old settings on it.
But if from the beginning everything snaps to a grid, it sure would make it easier.
Well, let's have a look and find out. Are you one of the happy people that can see the grid?
Yes.
Okay, so I'm just going to do a trick. I'm going to add transformer. I want that one. Okay, so I'm going to try to deliberately drop it in the middle of a grid. No, appears to let you drop it in the middle of the grid. And it doesn't snap.
I'm thinking about an independent setting that would say,
I know what you're talking about. I actually realized
snap everything to a grid.
Try control, holding down control key when you place it.
All right, so let me move and do control key, and then just hold the control key down and then land where I want, right? No, it's gonna let me do that.
Now there's a post I put in the chat window. there was a question, is there a snap to grid feature in the layout editor? And there was some mention about using the control key. I'm not sure how to use it, but I think most of these CAD programs should have a snap to grid setting that you set as a global preference. And whenever you place it, it automatically snaps it to the grid. It's
Dave, that link was for Eagle, by the way, right?
No, it's most CAD programs. Have
Yeah.
Most CAD programs today, yes.
Visio, you know, almost every CAD program I've ever used. I haven't used Eagle in years, but most CAD programs have some kind of a snap to grid feature.
Yeah, no, I'm just saying that post was specifically talking about Eagle, that's all.
You know, what's interesting is the wires snap to grid. This part did not. Do you mind if I do one more test or one more try? I want to drop a capacitor on. Okay.
Wait,
Rotate you, please.
Why don't you try turning the snap to grid off? That's probably what's causing the problem. You can draw horizontal, vertical lines and right into your symbol and not be snapping where you don't want to snap to.
Okay, so what I'm saying is there's no feature that I'm aware of called snap to grid. So I have the grid visible, but it's not necessarily snapping all parts, I think. Right, snapping wires. So are you saying if I turn off the visibility of the grid, it ought to work?
Give it a try. That's what I would do in AutoCAD.
We're going with it. Okay, so I'm just going to move you and just try. Give me a wire, please. This one's on grid or off grid? Okay, I think you're right. By turning off the grid, it works. So apparently the snap grid is associated with the visibility of the grid. It's only working for wires though. All right, so that was a long answer to a very simple question. I'm sorry about that. I've not observed this before. I'm usually drawing with the, I think I'm usually drawing with the grid on, by the way. Are there any other further questions that require the tool to be open?
Yeah, I've got a couple of questions.
Sure, Dave.
Let me lower my hand here. My
Which
hand lower. Okay, so yeah, support for other components. Do you find, it's a two-part question, do you find that it seems that the list of components is pretty extensive. Do you, is it extensive? And I guess
Okay, go ahead. Second question. Give me your second part too.
I was going to say, and is it fairly easy to import new components or new symbols?
It's really so easy to import new stuff. I'll talk to you about that now. And I think it's pretty comprehensive, or it's pretty good about the number of symbols it has. I think what you'll find is you won't find necessarily the footprint you want, but it's very easy to add libraries. So for me to do that, I will show you the footprint library in a second. So here's where you add stuff. What you do is you go to a vendor that supplies libraries. You usually find libraries, if you're finding the entire library at once, you're going to find it on GitHub. So DigiKey has its library on GitHub. I do not know if it's a complete library because I can see things on their catalog that I don't seem to be able to find in footprints, okay? But it's big. And what you do is you go to Preferences, Manage Symbol Libraries if you're in this particular thing. And since I didn't bring any symbols down, I'm actually going to do the footprint editor if you don't mind, because I've already done it. Manage Footprint Libraries. So what you do is you go to the global libraries, assuming you want to use that library. You have downloaded the library, unzipped it into a directory somewhere that you know, and you go to the bottom. You can see I've done it here. You set, please add a new library. Click on this, find your directory, and you're done. Okay, so it'll find it. I'm not going to do that if it's okay. You can imagine finding a directory. You set it to KiCad libraries and DigiKey, and it'll or transfer and select the transformer 2T directory, and it just adds it. Okay, so this one has been added by. I downloaded a transformer directory because I didn't see the one I wanted. DigiKey footprints, I took down the entire library. Wayne's footprints, I made a library. Just opened a library and I'm sticking stuff in there as I make my own. Okay?
How,
Go ahead.
I was going to say, how hard is it to create your own footprint? Is it fairly simple?
I think it's simple and easy. Mind you, when I've been doing this, I've been modifying other footprints. So I wanted to actually show you, in a way of a little story. I decided that I wanted to ground the case of my crystals. Now the footprint for this, because it's a 2-pin crystal, is actually a 2-pin footprint. So what I did is I made my own. And I changed the symbol to a 3-pin symbol. I didn't actually change the symbol because I found another symbol that I could rework. So here's a very simple change. Footprint editor. And I'm going to go down to my library. Thank you very much. Wayne's footprints. And I took my crystal and I changed it to a grounded thing. So this pin over here, I don't remember what it was, but it was, I think it was in the middle. I moved it over to the side and I changed its shape. So what I did was, I went to the properties. I told the tool that I wanted a rounded rectangle, I should say. Changed the dimensions a bit. Bob's your uncle. I've got what I want. I left it as a through hole here because what's going on is it'll essentially, when you make the PCB board, the hole itself is got copper in it, so that basically will touch the bottom side of the PCB board as where the ground is. Okay, so that was really simple. Now I've done some Manhattan ones in the same way. So this is the one that I would think I just showed you, the disc. I had this thing here and I said to myself, I'd like to make that Manhattan. Thank you very much. And that is because I want to basically I want to make a single-sided PCB board at home, and I don't want to drill holes. I hate drilling holes. Can I make it something similar to a Manhattan style? So I just select the thing here. I change it from, first I go from through hole, and I say, let's make that like a SMD, so it makes it solid for me. Red means it's the front. It's probably too tiny for me to use, so why don't I make it a rounded rectangle, thank you. Why don't I make the X size a bit bigger? Let's say it's 3. And then I drew it like that, and I thought, yeah, it's probably okay. Actually, to tell you the truth, where's my function key for everybody? Then I said, well, I have big, clumsy hands, so maybe I'll make this bigger. So my actual pads normally look quite a lot bigger than this. What can I show you? Discard changes. This is the change I made to a through-hole dip socket to make it topside SMD. So I made the pads a little bit bigger. Do you know that guy that makes me pads?
QRP, Rex.
QRP, right? So this is my attempt to make a QRP type knee pad that I can actually lay on a PCB board and connect wires to. So rather than soldering wires between knee pads, I'm going to do the PCB way. Okay. So that much is easy, and you can make a foot pad for anything. I have also made I made myself a. I'm going to change the diagram here. Stop. I'm going to open a new directory, a new project. Well, to tell you the truth, it's an old project. Because I'm not sure where I saved it. You're allowed to create you're allowed to create your footprints and your symbols inside a single project or across the entire library. And if you're careless, you might get the wrong answer, okay? So what I'm doing is, you might remember, I'm going to discard changes. I had a MK484, the 40 or 50-year-old IC. That's a one-chip radio. I'm going to try to put it onto PCB board, see if I can. So what I had is, I found a real filter for it that's a little bit better, and it has an odd pinout. So this one, I don't know if it's in. I've actually forgotten what I did, incidentally. So this one is basically, it's shaped like a, I think it's shaped like an 8-pin dip IC, except it's missing a boatload of pins. So I need to find my filter. Look, it's not there. So do I have anything showing? Nuts. Oh, I'm sorry, Dave. I wasted a lot of time here. I haven't brought it up from downstairs. So I made one for this. So basically, I started again with a 4-pin IC socket, and I dropped the pins that are missing. So you can see it's got 2, 3, 4, 5, and 1, and therefore 6, 7, and 8 are missing on one side. Okay, so that's easy. I've drawn a symbol before. I don't know what I did for. Oh, it's this one actually. Look at that complex symbol I made by myself. That is basically very simple. So what you're doing in the symbol editor is basically you're drawing the shape of the box and you're telling it the pins and their numbers. The pins and the numbers have to correspond. The number of the pin needs to correspond in the diagram to the number you give it to it in the PCB footprint. That makes sense? So if it's pin 1 on the diagram, it needs to be pin 1 on the footprint.
Yeah, it makes perfect sense. That's how you do it in, what's the tool I use? I can't remember what it's called. There's a tool I use. It's the same way. You create a number, then you go to the PCB editor or the pattern editor, and you pull it up, and you have to map the pins to the footprints.
Yep. And so I would say I've used LT Spice to try to make symbols. Maybe it's because I used LT Spice before this, I had an easier time using this.
Yeah, have you, Wayne, have you taken any of your designs and sent it off for a fab house?
I haven't done that yet. I have a little problem with my design that I have to fix first. I had two problems. Okay, the embarrassing one is to get the cheap rate, you got to make your board less than 10 centimeters wide, less than 10 centimeters long. It was 10.05 or something crazy like that. I don't know how I did that. So I had to I had to actually redraw it to get it smaller, right? Because it's really hard to, you can crunch all the pieces together, but you have to draw the box. Second thing is, if this is not the right footprint for the size of the SMA connector I own. I have the same size that are on our, the PARC VFO, and I've not been able to locate it yet. So I'm going to need to make one, unless I can, fix that in short order. So what I've been doing the last couple of days is shopping around for it. Now I have made a footprint. I'm using the same SMA connectors for the home built one, and I found an SMA connector that is nominally for this purpose, but the center pin is way too small to solder on at home, and I think I would bet it's not the same size as on the PARC Homebrew kit, so I can tell that it's not the one that was used there. So I'll probably have to make it. And by making it, what I'll do is I take this and I just shrink it. So these pins on the outside have to come in, because if I were to drop my SMA connector in it, the center pin would solder, but the other ones would be right in the middle of the green. That's the problem. So once I fix that, it's going out to the vendor. I'm actually going to spend the little extra, well, a lot extra you have to get the so-called rush mailing, and hopefully I might have it by the time we talk next. Yeah, so that's the plan. I plan to actually have this already in my hand today, but I'm very nervous about pushing the button on this until I find all the problems. And I didn't locate this until I actually made my homebrew PC board for the first time, or printed it, and then really recognized that it's not going to work.
Yeah, I'd be very interested in your experience, Wayne, sending it out to a fab house to see the process, how it works. I'd be very interested in hearing that.
Okay, so I've taken a lot of time on this, about 15 minutes more than I expected. It's my assumption that the PCB editor it's much more stuff. So it might be hard to get all the way through it in one session. I'm going to do it anyways, but there might be a lot of things to come back to. I mean, it's just, I don't know, it's kind of like double the number of things on the things that you might be interested in knowing about. So just to give you a heads up, when I was planning this thing, I figured we'd do 2 of these sessions, one for the schematic editor, one for the PCB layout. And if there was interest, you know, a boatload of special interest items that people wanted. I don't know how that'll work out, but I just want to give heads up. It's probably not going to be shorter. It might be the same length as this one. How's that? Any other questions?
Could you not put both connectors footprints on the board? So you could use either one?
I could, but my board would be, actually, yeah, my board would be well within the diameter. I'd have to make it sort of stretch it out this way. In fact, I don't have to use a coaxial connector. I don't actually have to have an SMA coax connector on it. I just have to have the pads, right? I want to have a soldering point. So it's already okay for that. But I want to be fancy. I want to be able to put an SMA connector on it if I want. I want to be able to solder a coax wire onto it if I want. I want to be able to do it with and without my transformer if I happen to be lucky in my matching. So, you know, I put a fair number of stuff on this just to be okay with it. Nobody called me on this thing, but you see I have pairs of capacitors. That's so that I don't have to have a variable capacitor to tune it down. I'm going to say 2 capacitors enough to get me close enough to the right standard value that I need for the bandwidth that I'm looking for, that kind of stuff. So that's how I build it.
Okay.
Okay. But yeah, absolutely, you can add more stuff on the board. I could, you know, I was thinking about, you know, do I want to make this thing sophisticated enough that I could make it a cone type filter? Do I want to add jumpers so that I can add capacitors between in here so that I can change the tuning? And I thought, no, I'll just make it simple. If I want to spend the infinite amount of time to get a delivered rate, it's about $5 US or something like that, I think, to get 5 boards. So call it $10 Canadian. I don't know what it comes in. Maybe it's $20. If I want to put a rush on it and get normal 1 month delivery, it goes up to 20, and then it goes up, I don't know, God knows what. More expensive than that to get it faster, right? So my plan is to just rush it out and see what I get. I want it to be workable if possible. I won't be gravely disappointed if it's a flop, because that seems to be part of the mix. But I mean, if you are doing stuff, I guess, like what this is, it's just what I'm saying. It's a kind of a thing you might want to pull off the shelf and use. So I'm going to get 5 crystal filters off of it. If I need one, I can, you know, pull it together rather quickly. So this kind of thing you don't need tomorrow. You just use the cheapest possible rate. You'll see it in, what, 4 months, 6 months.
Okay. Any more questions or comments for him?
Just a comment from Al. Thank you, Wayne. I was starting to play with KiCad probably 3 weeks before you announced you were going to do this presentation. So your presentation couldn't have been more timely. Thank you again.
No worries. And if you find some things you're having trouble with, you can contact me. I've probably not been able to do them as well. I know how to find stuff though. And actually what I've been doing lately is trying to, okay, I'm going to stop sharing my screen. I haven't made a PCB board for almost 20 years. So what I was doing was using KiCad to build a kind of like a topside surface mountish type board, and just learning how to get the darn thing to produce a PCB board that doesn't rub off or not stick on and that sort of stuff. So I think I've gotten past that now, but it's a good thing I chose to do that deliberately, because I was able to, spend a little the time on something real for me.
Okay.
All right, I need to get my face back up.
Anybody else? Go ahead, Peter.
Yeah, just a couple of comments. Thanks, Wayne. There was a couple of things in there that will save me a little bit of time that I didn't realize. I find once I learn how to do something, whether it's efficient or not, I just carry on with it forever. But one thing, when you had mentioned right at the very beginning that the use of millimeters, I find it definitely works much better using millimeters, because when you're measuring your components on the bench, it's easier in millimeters, and to convert into KiCad is a much better way to go.
Agreed.
As well, I think somebody's talking about footprints. Another one is, I think it's called Snap EDA, and they make a lot of footprints that are available for free. Mm-hmm. They do KiCad. Who else? They do a couple of them anyways. And so that's keep that one in mind. I can't remember which component it was, but I actually went there and I could not find the footprint, so I had to go and make one myself. And but I find the time it takes me to do this, because I don't do it very often and I'm not familiar with it. And then I don't do it again for 6 months, and then I go. It's almost like relearning the whole thing all over again. And a couple of things you showed us with the annotating and the symbol fields. Thank you for that, because a couple of little fine details in there I didn't know about, and it'll make things a little bit easier, especially the up and down or left and right when you're annotating your schematic. So anyway, that's it for me. Thanks, Wayne.
No worries. And listen, about Snap EDA, it's one of several I didn't bother mentioning today. There's a lot of places that you can find libraries of symbols. Some libraries like DigiKey are a complete library. So the other libraries are online. Find the part you need and download that alone. So in that case, what you'd want to do is drop a part that you've downloaded into a library that you've made for parts, because you don't want to have trouble finding all your parts. But those places, like, I agree, Snap EDA is one. I've seen a couple other ones that are open source providers of parts. They'll find anything. I just haven't sort of tried to use them yet. But they only bring you down a single part, and not a complete, catalog.
I got one final comment. On the Snap to Grid situation. I did a few searches on Google, and there's lots and lots of comments about that. So all kinds of people have been having issues with it. But the definitive one seems to be something like what Dave mentioned. And here's word by word what somebody said is the solution. Hold down the control key as you select the part, and its origin will snap to the displayed grid. So I don't know if that'll work, but that's what it says. So, and there's all kinds of comments in Google search.
Okay, we're just going to try that while you guys are chatting. I'll tell you if it works before we're done.
I think that kind of control used to work in OrCAD, I remember. So I think hitting that control key will snap to the grid.
Yeah, most of these CAD editors usually have that kind of some feature like that. where you could snap it to a grid, because then it aligns everything and makes it easy, right?
The problem with that is your symbol will have an origin to snap to, but now it has to have been drawn so that all the individual connectors are on the same grid pitch. If they're not, you're always going to have the connectors out of sync with the grid.
There was another comment that said that the actual grid that you choose may be finer than the displayed grid of points, so that you're snapping to a grid that's in between the displayed points. I don't know if that's true, but that was a comment.
That actually makes sense if you think about it.
Quite frankly, when I'm working in AutoCAD, I don't use the snap to grid. It's more of a hindrance. So that's why I was suggesting just turn it off. When you're drawing lines, you can constrain them horizontal, vertical, and it does much the same thing.
Not working for me quite yet, but I presume if I fuss with it, I'll figure it out. If I do find the right order to do stuff after the call, I'll put an email.
Okay, excellent. Any more questions, comments? No? Okay, Wayne, thank you very much. That was interesting.
You bet.
Okay. I guess next up will be me. So, as some of you may know, we were about 16 months ago talking about a buildathon, and the plan was to build a direct conversion receiver. Very simple. And just maybe a month ago, I finally got the second run of the board layout. So what I'm going to do is I'm going to share my screen, and hopefully this works. I want to share window. No. Whole screen. Let's try that. Oh, it won't let me. Oh, not me too.
Might be sharing application. If your window's open that you want to share, and then share the application.
Hang on a second here. It's not letting me share anything.
The screen that you want to share, Ken, is it open or is it minimized?
I closed it.
No, you have to open it. It has to be open, not minimized. And then you can share it via the application.
Just a Windows folder. I don't even get application on the list. Oh, there we go. Oh, I see that. Can you see my screen, guys?
Yep.
Okay, so a little history. This is version 2 of the layout. Kelly Gray, as I've mentioned, works for Humber College North. He graciously, always graciously, spends his own time doing our board layouts for all our projects. And they have a milling machine, so he's milled a board, a second version for this. So here is version 2. So this is the bottom side. This is where the soldering is done. And the top side. So this is the side that the components are inserted through. And the ground plane's on top. So basically we've got power supply coming in here. We have the antenna or RF connector coming in here, and we have volume
Ken, sorry to
control.
interrupt. Can you enlarge the one you're talking about, please?
How's that?
It's just frozen on the gallery view of. It's got all 5 photos. If you're seeing a large photo of one of them, sounds
Okay,
like.
let me stop sharing. Let me try this again. No, it's not showing it again. What a pain in the butt.
Open up the file in the photo viewer.
That's what I have. Share. Entire screen, no. Windows. No, it won't show the viewer. Damn it. Oh, darn.
Okay, Ken, you can punch me later, but I have a submission for next month's meeting. I'm going to be doing how to share screens 101 on Jitsi, little seminar.
Excellent.
We've been doing this for 16, 17 months now. Gee.
Yeah, I've never had so much trouble sharing a screen. Can you see this photo?
Yep, we can see the photo, but it's just small. That's all. Like we're seeing all 5 of them.
No, that's not. I'm actually showing a viewer,
No,
and it won't let me share it.
Can you just share your whole desktop, maybe? That ought to do it.
Well,
I always found that as long as the window is open that you want to share, then you're going to find it in the share screen function. But the window has to be opened; it can't be minimized.
So when I did it, my thing, I shared the entire screen, then I minimized the browser, and I actually had the KiCad screen underneath it. That's why it worked, I guess, or maybe contributed.
Okay, let's do the share entire screen. Okay.
Wait, Ken, did you sacrifice the chicken? You remember that step?
Sacrifice the chicken.
Yeah.
This isn't.
Minimize your browser. Okay, now bring up your picture. Click a picture. Yeah, that's your
perfect. Perfect.
Okay, so I got to do it that way. Okay.
Just today.
And then I'll forget next week.
No, it'll be different next week.
Yeah, when they make a change. Okay, so there's the bottom side of the board. This was all milled at Humber College. Top side of the board. So this is the side where all the components are inserted. So we have power in, RF in, volume control, and these 2 here and here. This is fine tune and coarse tune. So I actually started building it. I haven't had much time, but so here I've got the power supply all laid out, and it works. And I've also built the audio stage, and it works. So I have the power supply and the audio stage built. Now I haven't got anything else built to it, but you can test the audio amplifier by just taking a little screwdriver and touching the input with your finger, and if it hums, your audio amplifier is working. So hopefully sometime in August I'll have this all built. Here is the schematic. So we've got power coming in here, 9 to 12 volts, and power takeoff for the audio amplifier. We have a 6-volt regulator, which is powering the NE612. We have RF connector coming. Where is it? Oscillator coming in. And what we're going to have is a switchable bandpass. So the plans right now are for 40 and 20. We'll have to talk about making extra boards available if you want to experiment with it. And here's the audio stage going out to a speaker. Now, the oscillator, we've got it set up in such a way where you can, through this connector here, to switch between an external source for your VFO, or we're going to have a plug-in VFO. Just using a coil, capacitors, and a varactor. And I wonder if I can zoom in a little closer here. So we're going to have a fine tune here. Too close. There, we're going to have a coarse tune and a fine tune. And on the little VFO board, there'll be another one, another resistor, and a variable capacitor to set this board up for proper frequency. So that is it. I built the first version, and so did Frank, and we both built one of the 40-meter VFO board, and we also used the SIGGEN for a signal source, and it works quite well. So that's where we are at this point in time with it. I guess I'll have to finish building this little sucker and give a report, and if we're good to go, we can start ordering some boards and some parts. Any confessions? No? Okay.
Actually, I've got one.
Yeah, go ahead.
I think you said you were putting the ground plane on the top surface.
Yeah.
Well, I'm asking for a friend who's building a filter. Can you put a ground plane on top and bottom and connect them electrically, or is it just dumb?
You can, but just put it on one side as far as I'm concerned.
Okay.
You have to set up the vias correctly so that they connect properly together. Anyone else?
Thanks.
Yeah, no problem. Anybody else? Okay. So, has anybody else got anything to share or you want to talk about?
How much time do we have?
We're to what? It's 10 after 9 now. What do you want to go? Another 20 minutes?
Yeah. I'll go quickly with the project I'm working on right now.
Okay, go ahead.
After our, I think it was the mixer meeting, we talked a fair bit about the mapping your antenna. And of course, after talking about it for so long, I thought I guess I better go out and do something. So I built a board and cobbled together some existing stuff that I already had going on. There's the 8307 board and Arduino, of course, and then there's the data logger started to work on. Anyway, I went out and I put this in during the rainstorm. and I used a signal generator. And I just put 23 dBm, I think it was, on the antenna. Ran out when it wasn't quite raining so hard, and made a measurement. Then it came back in and took the signal generator away and went back out again, make a difference. And I was within 1 dB difference of that. So I was quite pleased about that. It was a good start. And then I think it was the next day, Dwayne had a suggestion of using GPS and a direct conversion receiver and all that kind of good stuff. And I thought, well, I've got all that stuff as well. Kevin and I started a project, I don't know, 8 years ago, Kevin? I don't know, 7 years ago? It's been a while. And the repeater footprint project. So I started to revive that. And that's all in this. That's right here. So there's a GPS data shield there, and underneath it's a Nuno, and of course the LCD screen. So it's been quite the learning curve to try and get myself reestablished with that board, because it's been so long, and I never did have it working properly originally. So at this stage of the game, I've got it. Well, I can get data across the serial port. I just can't get the data to save to the SD card yet. Anyways, it's a work in progress, but the nice thing is to revise some of these projects that have been sitting around for a long time, not doing anything, and find another use for it. I never did do the repeater mapping portion of it, but I think it'd be pretty good to get this going to do some mapping of an antenna system. So that's kind of where we are at the moment.
Peter?
Yeah.
What's the frequency span for that receiver you've got?
What, the direct convert? Oh, that's into. Oh, yeah. And here's the other part too. That's I just happen to have when we first talked about the PARC direct conversion receiver project, I built a prototype on one of the earlier designs. So, and again, another board sitting around, not really doing anything at the moment. So I'll couple that into that project as well. But I was aiming for 40 meters.
Yeah. Okay. I was wondering because I was just thinking about it might be useful on a range with VHF, UHF stuff too.
Well, that's easy to do because originally this project that I did was for 2 meters, and I had taken an old Puxon handheld, and I think I've told most of the story to most of the guys, but anyways, quickly, I took the earpiece that was in the handheld and I desoldered it, turned it upside down and glued it upside down back onto the circuit board. And then I took a wire jumper from that ear plug over to the RSSI chip and soldered onto that one. So now the RSSI signal is going to the earphone jack, and I've wired in. Bound to break something for sure. I just wired right directly into the Arduino the earpiece or the earphone jack or plug. So the RSSI data is there as well. So it's no big deal to change that over to for 2 meters, anyways.
Yeah.
Well, I mean, it's the front end. It just depends on how you want to do it. In this case, the RSSI data comes out of this particular handheld that I modified to suit.
Neat.
Cool.
Actually, I do have a question, Dwayne. When you were mentioning about a tight bandwidth for the direct conversion receiver for this project, how tight of a bandwidth were you thinking?
I mean, if you're doing something on HF, you want something to be able to go and take a look at the signal you've got. So you probably want, 5-10 kilohertz.
Okay. Thank you.
Anybody else have anything you want to discuss or bring up?
I've got a very brief show and tell.
Okay, go ahead.
Some of the Carex people have seen it already, but I'm looking for something I can use for an ASL rotor for UHF, VHF for satellites. And I managed to get a big camera ASL mount. And it's made by Burl, B-U-R-L-E, a German company. And this is what it looks like. It's really good German engineering. 2 motors, azimuth elevation, and really high quality German engineering. But it doesn't have, I think I showed some of you this before, but it doesn't have shaft encoders or anything, so you don't know quite where it's pointed. But it was suggested, I think by Drew, that I should use a 3D axis sensor, something that would, you could just attach to one of the antennas or the base, and it would give you feedback as to what the azimuth elevation was, and you could control the thing with a Arduino or something, but the feedback wouldn't be from shaft encoders. It would be from the 3D platform sensor. So that's what I'm thinking about doing. That's it.
That sounds pretty cool. Anybody else?
Yeah, I had a topic that perhaps we should bring up at this point regarding our meetings. Since things are starting to open up again, I guess this is a trial balloon, if nothing else, but seeing what the group has to think about going back to in-person meetings, at least for the once a month. Have maybe like a hybrid meeting schedule. Obviously, everybody's, that wants to go would have to be, willing. Fully vaccinated would probably be another, I guess, I don't know if you call it a stipulation or requirement or just a nice to have. For it, and also whether Simon, who is our host in the past, would be willing to continue on with that. So anyway, just I guess something to think about. I mean, good weather, we could have it outside at Simon's place if there's a suitable venue for doing that, and also remote in those that can't or at this point don't feel the ability to that they're able to make the drive to the in-person. But anyway, so obviously we've gotten all very used to this over the last year and a half, this format, but it's something to start thinking about now that a lot of things are we got 2/3 of Ontarians 12 and up that are fully vaccinated. Seem to be driving the case counts down and going in the right direction. So I don't know if we want to maybe do a poll, again, a little informal, anonymous, groups.io poll. That might be the best way of doing this. And that way, test the waters, so to speak. So I don't know if anyone has any comments on that. If so.
I guess the first step would be to maybe is Simon even wanting to carry on having meetings there.
Right.
He's had a rest from us for over a year now. He may not want to go back.
And he gets to go home at a decent hour at the end of the day.
Well, I guess it's also going to depend on how many people are going to show up.
Yep. Yeah, that too. Well, let's start with a poll. You want to put up a poll, Eric?
Yeah, I'll put up a poll, and that way, if it's 1 or 0 that want to go back to in person, then no need to bother Simon at the moment, and he'll see the poll too, right? So
yeah.
Thinking out loud here, this format has worked pretty good. Wondering now, instead of monthly in-person meetings, again, I'm just thinking off the top of my head out loud, meet quarterly or something like that, or and then have the rest of the meetings like we're carrying on now, and then just every once in a while meet in person.
Yep, it's an option too.
My preference, that's my call. My preference actually is the Zoom meetings or the Jitsi ones. I think they're pretty good this way. I would probably prefer to do it this way rather than go to a meeting once a month. I don't know. Quarterly sounds good with the Jitsi meetings. The rest of the time that would work, I think. But I kind of like the Zoom actually.
And
For the
actually,
Jitsi.
if we're going to do it like, a couple of times a year, 3-4 times a year kind of thing, the in-person meeting should be longer. We should maybe, instead of having it on a weekday, maybe we look at a weekend and we do like a morning or an afternoon kind of thing, right? And we hang out for like 4 hours kind of thing, because then that's worth it, because then we could organize it so that we have stuff to show, stuff to talk about.
I like that idea. That's a good idea, because we could do that more or less during the warm months, and then the other the regular meetings have as a Jitsi session, and then the mixer can carry on as a Jitsi as well.
I like the Jitsi.
Are you volunteering your place, Eric, for the quarterly meeting?
Absolutely. Poolside in the warm weather and in the coop in the inclement weather. So.
Ooh, those chickens.
There's a roost for each one of you. So you just have to keep the eggs warm. That's all. That's the bargain.
Yeah. Don't forget about the donkey.
And the donkey, yeah. Extra entertainment.
Well, that's fun. Take care of that.
That's the punishment donkey.
Pin the tail on the donkey.
Anyone who asks too many questions, the person who asks the most questions or put the most things in the chat window, I like that, has to ride the donkey.
Okay. Well, let's.
Yeah, we'll float it around.
Yeah. Let's put a poll up, and maybe when the poll's done, we could maybe start a message on Groups.io and see how people feel. I'm not quite sure. I'm sitting on the fence whether to keep it at home or to do it in person.
Yeah, I like that warm month in person, longer one, like Dave suggested, maybe on a Saturday or something. That sounds like not a bad idea. Of course, every week's a Saturday for me, I suppose.
Anyway, guys, I got to run, so I'll see you guys. Good to see you.
All right. See you later, Dave.
I like the warm month idea also, and also maybe we can even make it make the online meeting twice in a month, right? So
Yeah. No, that's a good idea. I mean, like every 3 months instead of every month would save Dwayne a lot of gas. That's how I figure it too, right? So.
The online allows us to have the Carricks people and people from anywhere come in and join us. So
yeah,
in that regard, a few of these online seems a good idea.
Well, between gas and dinner and stuff like that, meetings close. I'm pretty close to $100, I guess. About $80, I guess. I'm not complaining, mind you. You guys,
yeah, but don't forget, Dwayne's paying a quarter of the price of gas than we are.
Yeah, okay. It's also 20% smaller a gallon.
All right, folks. So what else? I think that's about it for the evening. I'm on vacation starting Friday, going camping next week. I haven't decided if I'm taking a radio with me or not, but if I do, I'll post something on Groups.io. Let you guys know.
Take two. Okay.
Don't
forget the mixer next month on the 4th.
Starting this Saturday.
Yeah. Take video of yourselves and put it on YouTube.
Yeah. If I take 2 radios, I'll have to leave both tents at home because I won't have room in the car. Okay, folks.
Okay.
Have a good night.
Have a good night.
Good weekend, and we'll all talk later.
Good night, everyone.
Thanks.
Night.
Good night, everyone.